Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch, where we implementing, neural networks from scratch in Golang, where we implementing, a neural network from the scratch, and we're implementing all of the things like all of the layers, neurons, operations, activations, functions, and I believe even training. And I'm using this book called Neural Networks from Scratch in Python, and I had to make one day off from the recording. So originally for the past 3 weeks I've been recording 3 times. I've been recording 6 times in a week, but during this Monday I had to deal with some bureaucracy stuff. I had to made a trip to another city to deal with the bureaucracy stuff, and it took me like the whole day. Maybe I will manage to replace this recording day with another day, so I will write 2 series at the same day, but we'll see. And in the previous video I ended up with the implementation of backward path for the dense layer and for the dense layer and for the rel activation function. And I remember that I placed this to do test backwards path because I'm not sure that I implemented taking the dimensions and multiplications correctly, because, for the relu it was actually pretty simple because it doesn't change the dimensions of the array, but for the backward path it's a little bit different. So what I want to do is I want to run and see if I have some issues. And in order to do this, I think there is an example of the code that I can replicate with it. Yeah, so I need to have the inputs, the weights, and that's right, I will use the same. So we should create, where is it? The same inputs and the layer. So I'll try to replicate this. Okay, so we have, I think the d values, it's the one that will, yes, the d values, that's the array that will use as an input param for the backward calculation for the current layer. So yeah, d values equals and I think it will be like 3 by 3 and float. Okay. Okay, something has broken again. Still not working. Float 64 the text. Oh, right. It's like this. Okay, something broke with the LSP, but okay. So 1, 1, 1, 2, 2, 2, 3. Expected aberrant, but found. What happened? Oh, now I see. Okay, that was the problem. Okay, then we have inputs and so it should be 3 by 4 and what? Okay. And first, second. Oh wait, that's incorrect one. Once again, inputs 1, second, and third. Yes, and we have weights, which is then the same 3 by 4 of float 64, right? And we have the first, the second, and the last one. Okay, then I'm going to create the layer, which is layer, and its inputs, weights. Oh no. Weights and biases. I need biases. That should be 1, 3, 2, 3.5. Okay. And the layer weights equal weights, layer. Okay, so we created, then we need to actually layer forward inputs, right? Then we need to create activation function, which is this one, right? Then we do activation forwards, and we take in a layer output. Okay, that should work. Okay, that works. So the next thing I need to do is, let's optimize and test backpropagation here. ReLU activation simulates derivative with respect to input values. Okay. Yeah, but this is the... So at first we need to... Wait, will it return? No, then I need to do activation backward. And for the backward, we need to take D values, right? No. Okay, so the forward pass, we have the layers output, we have the ReLU outputs. For the backward, we take in taking the activation output, right? That should calculate the D inputs. And then we should call layer backward, or wait, have D values. Pass in gradient from the next layer. For the purpose of this example, we're going to use an array of incremental gradient values, but it's not used anywhere, right? Okay, some of the examples are really confusing. So here it's actually not used. So, but we made a copy, but actually it should be D values, and here it should be activation D values, right? Not sure. Yeah. Dimension mismatched. That's okay, but to which moment? Right. Real activation simulates derivative with respect to input values from next layer as to current layer during backpropagation. So the layer's output, yes, it will be a two-dimensional matrix, not the one-dimensional, because the layer's output... What's the layer's output, by the way? We have 3 by 4, 3 by 4, 1 by 4. Layer output team. Okay, so the result is 3 by 3 and the D values from the previous one is 3 by 3, so it all makes sense. Okay, which means that the activation D values should be the same, right? 3 by 3. It's activation dims. Yes. Okay, so I have the problem with backward because it takes the input from the activation, which is 3 by 3, and it should output and it should output 3 by 4 in my case, because yes, so the input from the previous layer 3 by 4. Okay, where I'm... Which one? Go main dense layer 62. Okay, so the first one is actually. So the D weights we should have 3 by 4. Okay. Can I do this? Can I take the... Can I evaluate this one? No? I'm trying to see if I can run the expression here. So it's layer, inputs, themes. Function calls are not allowed without using call. Okay, maybe like this. Okay, so it's 3 by 4. And then the values themes 3 by 3, and I should end with 3 by 4. But d values t. Okay, it's still 3 by 3. Wait. Okay, where is the class? How I ended up like this? Okay, for the d inputs, it's d values weights t. Why I wrote something like this? It's layer inputs t transposed and d values. Okay. Right now we have here. Really? 73. Okay, and right now 3, and weights we have 4. So we take in the number of the weights, number of calls. Again, call zeros. Call not at safe point. Okay. Three, okay. D values 3 by 3. Layer weights is 3 by 4. Yes. That should... Okay, so the transposed will be 4×3. And 3, 4. Okay, I've spent some time trying to debug it, and I'm not sure where I made a mistake, so I will try to implement it once again. So let's start from biases. And for the biases, we create in the new dance, which is 1 by so we're taking the D values and we summing across columns, right? Biases, roles, okay. Define the roles, biases, roles. I'm removing this. Okay, so we have 3 rows. You know, there are some days when you cannot think at all. I think this is the one that I had. For example, okay, we have the D values, we have 3×3, we calculating some among the first axis. Some values do this over sample, first axis kept in since this by default will produce a plane rule. Okay, so it calculates through the columns, right? And then returns. So we calculating through the columns. Okay, let's check it again. Actually, I can check formatted and layer biases. Two, 3, 0.5. One bias for each neuron. Biases are the so we have the D values. Where is it? So I'm using this example, right? 1, 1, 1, 2, 2, 2, 3, 3. Okay. So we... No. It looks like we're going through... Going through the rows. Yeah, and we're calculating through the rows again. So by... Okay, so that should be actually calls. We should go through the... And instead of this row, let's call view. Okay, that's better. So this is what is expected. So we should have this, this, and this. Okay, gradient and params. Next one. Next one is gradient on weights. And okay, so the second I want to implement the d weights, and for this I'm going to take rows and calls. Okay, so the first one is what is the first one? Inputs. So the layer inputs dims. Second one is from the transposed. Second one is d-values dims, right? So then we creating the d-weights and should be math new dense with m be nil. Right, and it means that then layer d weights product is the multiplication of inputs, layer inputs, t transposed, and the values. Okay, then it's, you know, one of the examples when it's better to start from the scratch. And the last one, gradient on inputs. Again, then we multiplying d values and transposed weights, so it's d values dimensions. Then this one should be layer weights dimensions. Then we take in layer the inputs equals to math Newton's MP new and layer the inputs product between the values and weights. Oh, right, math. Dimension mismatch. Oh, right. This is interesting. Previous time I had problems with this one. Maybe something is not changed. Three. We have d values 3 by 3. We have weights transposed 4 by 3. Yeah, it's true that, well, there is a mismatch, but I don't understand what I'm missing. In this example, we have the rule. Okay, I need to debug these codes once again. So inputs. Okay, relu shape. Okay, d values is 3 by 3. But I have d values. Oh, okay, 3 by 3. Input I have 3 by 4. Weights I have 3 by 4. Bias is 3. Let's optimize this by propagation here. Relu activation simulates derivative with respect to input values from the previous. Okay, so it's actually just the confusing Okay, let's think about this. So the... No, okay, it's... Okay, so the D value is 3 by 3, right? The inputs 3 by 4. What I have here, but I have 3 by 3. But weights... What? Recall that we keep weights transposed. Wait, so they transpose it 2 times? Why? Number of inputs, number of neurons. So I don't need to transpose it. So you want to tell me that that was the problem? Where? Okay, I want to compare all the results. D weights and D. Okay, so D inputs. Three by 4, 3 by 4. Oh, I have the randomized. No. No, I have the concrete one. You know what? I'm feeling like the best approach would be to stop for today. I mean, I really don't understand what's going on. I'm just feeling stupid. And okay, since I'm feeling like I need to stop for today. I have no idea what's going on with me. And tomorrow I will continue because I'm kind of a little bit confused. Is it me or is it the example? Probably it's me. And yeah, I mean, I should have the same results, but I'm not sure if am I passing the incorrect data in the chain of the data. So for example, I have the D inputs from the D values, and maybe that's the whole problem, but at least I don't have the crashing, which is good, but the numbers are very different, so I need to understand what's going on. Yeah, weird. Okay, thank you for watching, and I see you tomorrow. Bye bye. And yeah, maybe if you saw where I'm being stupid, and maybe I just don't see a very simple error, I would appreciate it. But if not, I will fix this tomorrow. Bye bye.